Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Welcome to IAGI Technical Conference 2020. Thank you for the occasion. At the moment, I would like to present our paper which entitled as Revealing Fracture Basement Reservoir Potential through Hydrocarbon Migration Model in Pendopo High, South Sumatra Basin. Okay, before we start the presentation, let me introduce myself. My name is Gita Septianti Srikandi, and I've joined PERTAMINA IPI since 2011, CNG in Tiumbiru area, and now I'm working as Sumatra Exploration Geoscientist. Okay, this is the outline of the presentation. This presentation will be divided into 5 sections. First is introduction. We'll talk about regional geology, background, and objective of the study. Second is basic theory, data and methodology, analysis and discussion, and the last but not least is summary. Okay, let's move on to introduction. This is the pre-tertiary depth map, or basement configuration map. This is the central Palembang Deep, and this is the area of Suban Field and Dayung and Sumpal Field that proven has a fractured basement reservoir. And this is Jirak Field that discovery hydrocarbon accumulation and basement interval. And this is Pendopo High, the study area. Based on location, Pendopo area is surrounded by proven fracture basement field, such as Jirak Field and Suban Field. And recent discoveries, especially in Jirak Field, has revealed the fact that basement layer has been more captivating to explore. So, the objective of the study first is to describe migration pathway in Pendopo High from source rock in central Palembang Deep to fracture basement reservoir in Pendopo High, in order to discover new hydrocarbon accumulation fracture basement reservoir other than Jirak existing field. We will talk about regional geology of research area. Actually, the research area is 200 kilometers away from Palembang, and it covers 15,000 square kilometers. Geologically, you can see in this figure from BISOP 2001, Pendopo High is situated in the western portion of South Sumatra Basin area. This area is bounded to the north by Central Deep Palembang, to the east by Basin Mountains, to the south by Little Piggy Trough, and to the east by Lematang Depression. River Tupulonggono, 1992, there are 3 major tectonics in South Sumatra Basin. This compressional phase in Upper Jurassic, Lower Cretaceous, extensional phase in Upper Cretaceous, Early Tertiary, and the last one is compressional phase in Middle Miocene of recent. As we know that these major tectonics have been expressed as regional alignments. Upper Jurassic event produced as northwest to southeast oriented strike slip, or we call it as north 300-degree strike slip alignments. The structure was driven by movement of Indian Ocean Plate to the northwest. The structural alignments were related to Jurassic Cretaceous granitoid trends in South Sumatra. In addition, the granite basement in Jirak Field, southern part of this Pendopo High, have been age-dated and found to be 90 million years ago. The pre-tertiary rocks were intensely folded and were intruded by igneous rocks during the time. The next tectonic event is the extensional phase in Upper Cretaceous to early Tertiary, as expressed in short to not structural climate trend. The extensional stage phase of the basin led to the reactivation of the basement features. In the Middle Miocene, South Sumatra Basin entered the compressional regime that reactivated basement fault. So, if there are three major requirements for fracture basement reservoirs, such as paleo-high, polytectonic event, and facing to the kitchen, this area is absolutely meets those requirements. And as we know, this extension in early tertiary resulted in opening up of numerous half-grabens. The overall tertiary depositional field of the South Sumatra Basin began in the Eocene. Started by Lahat or Lemat Formation, Kasai Formation is the youngest one. Af and Lahat are the main source rocks, meanwhile Gumai Formation is possible source rock. Okay, that's enough for the introduction. Let's move on to the basic theory. Actually, basin modeling has been performed since about 1980 and become fully three-dimensional in respect to all important processes. Basin modeling is dynamic forward modeling of geological processes in sedimentary basin over geological time spans. Most important processes are deposition, pressure calculation, heat flow analysis, petroleum generation, expulsion, and then the last one is migration and accumulation. These several geological processes are calculated and updated at each time step. Actually, a primary target of petroleum system modeling are hydrocarbon exploration risk factors. They are the hydrocarbon charge, the reservoir quality, the trap capabilities, and the timing relationship between charge, reservoir, and seal. Thus, basin modeling combined with probability analysis can be used as a decision support system for exploration risk management and risk assessment. This is the seismic data availability map. The model has been conducted for more than 600 2D seismic lines and 17 3D seismic cubes. In addition, well data of variable quality and completeness were incorporated from 27 wells. Wireline logging, cutting data, sidewall core, and conventional core from Zirak-Z and some other wells in Jambi, Pendopo, have been reviewed as part of the study. This is the Zirak X, the Discovery 40 through BOPD, and this is the Zirak-Z, the core of basement of Zirak has been dated as Cretaceous granite. Petroleum system evaluation in Pendopo High has been determined from 1D, 2D, and 3D modeling. In order to make the estimation, the model has been performed by geochemistry and fracture analysis. We start with building model, interpreting some horizons, creating the depth structural maps, and then combine it with edge assignment from geostratigraphic analysis, building the facies map, and adjusting some boundary condition. And then we go to the simulator, we run basin modeling 1D, 2D, and 3D. We build migration accumulation map, petroleum critical event, and then we validate it with the real well or field status and back for with basin modeling 1D and 2D. Basin modeling actually required a complete stratigraphic interval map from basement to the youngest layer, including the erosion map associated with Paleoclaystocene compression. The amount of erosion have been calculated from sonic wireline data and vitrinite reflectance data from wells. And the basement has been divided into non-weathered basement and weathered basement in order to input our parameter to the model. This is the basement interpretation from the seismic. The determination of fracture basement reservoir properties come from field checking structural data measurement, image-log analysis, petrophysical analysis, and geomechanical model evaluation. Image-log and petrophysical analysis has been conducted from 9 wells that had penetrated the basement layer in Pendopo High and Jambi area. Furthermore, the model fracture characterization from untracking attribute has been used to determine fracture intensity, porosity, and permeability of basement reservoir. The geochemical analysis has been carried out from 11 wells. Talang akar and lahat formation considered as main source rock in South Sumatra. Another potential source rock in the area was Gumai shell that had good TOC, but have low maturity level. The map show us that there are various value of TOC in each layer, and the geochemical analysis of lahat and talang akar formation from several wells and field data indicate type 2 to 3 kerogen with average TOC 4 to 5%. Range data has been generated from biostratigraphic analysis of tertiary layers and radiometric age dating of basement interval, and the data has been used for indicating the range of each layer, and furthermore, the biostratigraphic data has been used for describing the paleo water depth map in particular age. Other input data is capillary pressure from core MICP measurement. Okay, it is well known that highly permeable features such as good quality reservoir or faults can act as conduit of petroleum. In migration and accumulation model, in fracture basement, considered the alternatives. In this case, we use one was as flow path models, and the other two are hybrid flow simulators, hybrid between Darcy and flow path, and the third one is invasion percolation method. Other than modeling migration alternatives, we use a variation of fault or fractures models that are divided into 4 different fault types. It is open faults, closed faults, semi-permeable faults, and combined faults. So in total, we built 12 scenarios of models migration for this area. As we mentioned before, that we built 12 scenarios of migration model. This is the map from flow path, migration model, hybrid of Darcy and flow path, and invasion percolation. The models show there is high hydrocarbon saturation in Suban field that good for calibration of hydrocarbon model in Pendopo High. And after the calibration into Jirak and Suban field, we found that open fault with hybrid flow method has been found to be the best fit models. And besides the calibration into the proven field, calibrate the model with 1D and 2D models. So the modeling has been calibrated back and forth between 1D, 2D, and 3D models. And the models has been calibrated with head flow map and sediment water interface temperature as boundary condition for burial history analysis. And this is cross-sections of transformation ratio from Suban to Pendopo High. From transformation ratio sections indicates source rock in the center of Sumatra Basin, Central Palembang Deep especially, as have been 95% transformed into hydrocarbon, but in the lower part, it's only 40% that has been transformed. And it's indicate that the hydrocarbon is still generating in the basin. And this is the 3D migration models. From the migration models, it suggests that the general trend of hydrocarbon migrations comes from Central Palembang Deep. And the accumulation model shows high hydrocarbon saturation in several highs in Pendopo area. At least there are 11 sweet spots that has been identified. This calibrating 3D modeling indicates hydrocarbon accumulation is promising and place hydrocarbon amount in Pendopo High rather than Chirac field. Well, this is the summary of the presentation. Fracture basement reservoir in Pendopo High have promising potential due to the geological position. And based on basin modeling, there are some more opportunities of fractured basement clay in Pendopo High. But we have some recommendation for the next study. The modeling is preliminary hydrocarbon potential indication only, so we need further evaluation for prospect maturation and well placement. The evaluation that are needed in the fractured basement area are critical stress and elastic dislocation analysis. As George P. Box said, all models are wrong, but some are useful, and at least we try. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.